Today we'll be looking at matrices and we'll be solving the simultaneous equation 3x plus 2y is equals to 4, that's equation 1, and 5x minus 4y is equals to 14, that's equation 2. So this is a linear simultaneous equation with two variables, x and y, and two variables, two equations, and then we'll be using matrices. Remember, matrices is the plural for matrix. So in solving the simultaneous equations, we'll be looking at several methods through which we can solve the simultaneous equations. We have the elimination method, we have the matrices method, we have substitution methods, we have graphical solutions, among others. In two of the previous videos, you see the link at the end of this presentation. At the end of this video, we already treated the elimination methods of solving simultaneous equations. But in this particular video, we'll be using matrices to solve the given simultaneous equation. So what we are looking at is two variables in this particular case, and our two variables are x and y. And when you have two variables and you have two equations, you can conveniently solve the simultaneous equation. So we'll just try to define what a matrix is. We'll be defining a matrix. A matrix is simply an array of numbers or mathematical objects arranged in rows and columns. I come again. A matrix is an array of numbers, or you can also say an arrangement of numbers or other mathematical objects arranged in rows and columns. Now, the contents of this matrix are called entries or elements. The contents are called entries or elements. Now, this is our equation 3x plus 2y is equals to 4, equation 1, and 5x minus 4y is equals to 14, equation 2. So what we'll do is to put this in a matrix form so that we can solve the simultaneous equation. We'll put it in a matrix form. So this is the sign of matrix. So what we'll just simply do is to extract the coefficients of x and y, and then we put it inside this matrix. So you can see the coefficient of x and the coefficient of y in equation 1. You have 3 and 2, and then we have the coefficient of x and y in equation 2. We have 5 and minus 4. So these coefficients, what are they multiplying? They are multiplying x, and then they are also multiplying y. And generally, the product of these multiplications give us what we have on the constant side, on the right hand side, which is 4 and 14. So equations 1 and 2 has hereby been expressed in a matrix form, as we can see below. 3, 2, 5 minus 4 into x, y is equals to 4, 14. Now when we have the 3, 2, 5 minus 4, we have a 2 by 2 matrix, a 2 by 2 matrix. That is 2 rows and 2 columns. Next on the right, we have a 2 by 1. That is where we have X and Y. We have a 2 by 1 matrix, 2 rows and 1 column. Similarly, where we have 4 and 14, we have a 2 by 1 matrix, 2 rows and 1 column. So in multiplying the row and column, so we have 3 multiplied by X. We're looking at equation 1. So 3 multiplied by X gives us the 3X, and then 2 multiplied by Y gives us 2Y. And that gives us the first constant on the right hand side, which is 4. So that is rows multiplying columns. That is rows in the first matrix multiplying the column in the second matrix. Now the same thing applies to equation 2. We have the row 5 and minus 4 multiplying the column X and Y. So 5 multiplied by X is 5X, and minus 4 multiplied by Y is minus 4Y, all equating to the constant on the right hand side, which is 14. Now the coefficients, we can call that matrix A. Where we have the X and Y, we can call it B. And where we have the constant, which is the solution, we have 4 and 14. So A times B is equals to 6. So AB is equals to C. I beg your pardon. A times B is equals to C. A times B is equals to C. And A times B is equals to C means AB is equals to C. If we want to solve for B, solving for B, so because the whole idea is that we want to solve for X and Y, and X and Y is equals to B. So solving for B, we divide through by A. So we have, and dividing through by A means that A is now A inverse on the right hand side. So B will be equals to A inverse, that is A raised to the power minus 1 times C. Let's look at that. AB is equals to C again. When we take away the A, that is divide through by A, we have B. And if we divide through by A on the right hand side, that division by A, it now becomes A into the inverse. That is A raised to the power minus 1. So the formula for A raised to the power minus 1, that's the inverse of A, is equals to 1 over the determinant of A times the adjunct of A. 1 over determinant times adjunct of A. So we have the matrix form of the equation, and we have said that B is equals to the inverse of A times C, and we know what the inverse of A is. That's A raised to the power minus 1 is 1 over the 1 over the determinant of A times the adjunct of A. Now what is the determinant of A? So that's how you express the determinants, and we'll see how we'll solve this now. So if we look at the matrices above, we know what A is. A is that matrix that has 3, 2, 5, and minus 4. That's what A is. So the determinant of A is simply 3 times 4. So 3 times minus 4, that is the red area that was just circled now. That is 3 times minus 4 minus 5 times 2. That will give us the determinant of A. So we just simply express it. We said 3 times minus 4, and then we subtract 5 times 2. That gives us the determinant of A. 3 times minus 4 is minus 12, minus 5 times 2 is 10. So minus 12 minus 10. You're owing 12, you're owing another 10. That gives you a total of minus 22 that you're owing. So our determinant of A is equals to minus 22. So let's solve for the adjunct of A. So A is the matrix that has 3, 2, 5, and minus 4, 2 rows and 2 columns. All we simply do, let's look at it above, is to exchange where minus 4 is and 3. Exchange where minus 4 is and 3 in the matrix above. Exchange where 3 and minus 4 are, and we can see that as shown. Then where we have 5 and 2, we retain them where they are. However, we change their signs. 5 is positive, we change it to negative. 2 is positive, we change it to negative. What we have is we have successfully provided the adjunct of A. I'll do a more detailed video on determinants and also adjuncts, but for now this is what it is. It's very straightforward. Let me come again for the adjunct. Look at where you have 3 and minus 4. Exchange them. So where 3 is, it moves to the position where minus 4 is. And where minus 4 is, it moves to the position where 3 was. Then looking at 5 and 2 in the matrix above, you retain where they are, but you change their sign. So it is plus 2 above. When we are making the adjunct, we change it to minus 2. It is plus 5 below or above. When we are changing it, we'll change it to minus 5. So what we have there is the adjunct of A, and above also we have also calculated the determinant of A. So therefore we can combine the two to have the inverse of A raised to power minus 1. So let's look at the formula again. A raised to power minus 1 is equal to 1 over the determinant of A times the adjunct of A. And we have both the determinants and the adjunct. The determinant is equal to minus 22. The adjunct of A is, as we have seen there, so we'll just combine the two. That's both the 1 over the determinant times the adjunct. So this gives us A raised to power minus 1. But remember that the formula for B, remember that B is where you have your X and Y, is equals to the inverse of A times C. So we have the inverse of A, and then we multiply it by C. Our C is where the constants are 4 and 14. So what we'll do is that we'll leave the 1 over minus 22 outside the bracket, and we will get the resultant value for the product of those matrices. So before we do the solution, remember we have the row minus 4 and minus 2. We'll multiply by the column 4 and 14. So what we'll say is that 4 minus 4 times 4 minus 4 times 4, then we will add minus 2 times 14. So we are looking at the row minus 4 and minus 2, and then we are looking at the column 4 and 14. So we'll first multiply minus 4 times 4, and then we'll add minus 2 times 14. So that gives us the value at the top. Then let's look at the second row below, which is where we have the minus 5 and 3. So that minus 5 will multiply the 4, and then we'll add 3 times 14. So that's what we have below. So let's just simplify this. So when you say minus 4 times 4, you have minus 16. And then when you have minus 2 times 14, you have minus 28. So you have minus 16 minus 28, as we can see below. And then when we have minus 5 times 4, we have minus 20. And then when we have 3 times 14, we have 42. Let's just simplify this further. So we have b is equals to 1 over minus 22. So minus 16 minus 28, you are owing 16, you are owing 28. You are now going to owe 44. So it's going to be minus 44. Then you have minus 20 plus 42. You can rearrange it and say 42 minus 20, which is 22. Now that you're 1 over minus 22, you multiply it by the top, and that's the negative cancels out the negative. 44 divided by 22 is 2. So we also multiply the 1 over minus 22 by the base, and then you have 22 over minus 22, which is minus 1. So what we have is that we are saying b is 2 and also minus 1. And remember, what we have on top is the x value, and what we have below is the y value. So our x is minus 1. Sorry, our x is 2, while our y is minus 1. I come again. Our x is 2 and our y is minus 1 for the simultaneous equation. However, we will do a quick check. What check are we doing? We have two equations, equation 1 and equation 2. We have equation 1 and equation 2. We'll look at equation 1 first. Equation 1 has it that 3x plus 2y is equals to 4. So we'll simply bring out the 3x plus 2y, substitute the values for x and y, and see whether it will give us 4. Equation 1 has 3x plus 2y, so we'll simply simplify. So we'll substitute x. What do we have as x is 2? So 3 into 2. What do we have as y is minus 1? So 2 into minus 1. And then when we simplify, we have 3 times 2, which is 6. And then 2 times minus 1 is minus 2. So we have 6 minus 2, which gives us 4. So we see that this value of x and y satisfies equation 1. So we'll have to also do a final check on equation 2 to be sure it is also satisfied by x is equals to 2 and y is equals to minus 1. So we'll do a check also on equation 2 this time around, where we have 5x minus 4y is equals to 14. 5x minus 4y is equals to 14 is equation 2. So in this particular equation, we will be substituting x to be equals to 2 and also y is equals to minus 1. So 5x minus 4y in equation 2 should give us 14. So we have the 5x and we have minus 4y. We will substitute where x is equals to 2 and y is equals to minus 1 and simplify and see whether we will get 14. So we have 5 into 2 minus 4 into minus 1. 5 times 2 is 10, and then minus 4 times minus 1 is plus 4. So 10 plus 4 is 14. 10 plus 4 is 14. 10 plus 4 is 14. So what we have now is 3x plus 2y is equals to 4 and 5x minus 4y is equals to 14. And we have solved for x to be equals to 2 and y is equals to minus 1. We can confidently conclude and say that the solutions for x and y above, that is where x is equals to 2 and y is equals to minus 1, satisfies both equation 1 and 2, and therefore they are correct. Thank you.